Hi guys, this is Abdurrahman Gilal, and in this short video, I'll be giving you a brief, explanation of different security models, or I would say important security models. As we know, the information security models are formalized systems that specify which individuals should have access to data and how operating system should manage the access control. So these models offer mathematical mappings of theoretical security goals, providing a structured approach to implement security measures, right? So let's say security models can be based on various theoretical foundations, so including formal computing models, distributed computing, computation frameworks, access right structures, or combination of these all approaches, right? The sophistication of security models may vary from straightforward access control list to the complex mathematical formulation that account for distributed system dynamics, right? So the first thing first we have to understand is the CIA. So when I say CIA, it's not the spying guy, So CIA is confidentiality, integrity, and availability. So basically, confidentiality, as we all know, ensure the sensitive information is accessible only to authorized, individuals, and preventing unauthorized access to protect our data through classification mechanism and access controls, right? And there's a second thing that's called integrity. So maintaining, assuring the accuracy of completeness of the data or over its entire life cycle, preventing unauthorized modification, of course. So when we say integrity, so I'm trying to say that authorized people can modify, unauthorized cannot. So unauthorized modification of information through validation mechanism has to be prevented, right? The last one is availability, right? So here we are ensuring that the users have reliable and timely access to information and associated assets when needed, through redundancy and is also recovery procedures. So the primary objective of any security model is to maintain CIA trait. So this is the foundation that we have to understand, right? So CIA, like confidentiality, integrity, and availability trait of data while providing a systematic approach to access management. So security model achieve these goals through multiple mechanisms such as access controls, as I say, or robust authentication system, continuity authorization framework, functions and right regulations, and comprehensive activity monitoring and protection of data, sensitive data assets, right? So the first model that I'm going to discuss is called Bell-LaPadula model, right? So basically, it was developed back in 1970s. There were two researchers. One was called David Bell and Leonard LaPadula. That's why we call Bell-LaPadula, right? So Bell-LaPadula model stands as one of the earliest and most influential security framework. This lattice-based security concept established a multi-level security system with clearly defined access rules and security classification, such as like top secure, secret, and confidentiality. So you have different layers of classification. So let's say so we have three rules implementing two major concepts, right? So first one concept called no read up. So let's say you're a user, you are a subject of the data. So you can see the data at your level, whatever level you are. Let's say you are at secret level, let's say. So you can see that. You can also read what has basically accumulated that overall information, but you cannot go up. So that's why we say reading at your own level is allowed and reading below the level is also allowed, but no read up. You cannot read beyond what's up there. So that's where we call it a simple confidentiality rule. So only read, but cannot read. So no read up. We cannot read up, which means no read up. And then the star confidentiality rule, that's the second rule. So basically, this rule says you cannot write down. So when you write down, basically you modify what you got. So you cannot write down. So, but you can write up, which means you can put the request up there, or you can, write at the level that you have, but you cannot write down. So the level that you have, you cannot go below that to write anything. And the last one is called strong star confidentiality, which does not give you anything beyond your clearance level. For instance, that you are at level number 2, so you only can access level number 2. You cannot go up, you cannot go down. So it's like when I say no read up, so I'm saying basically if you are at confidential level floor, you cannot go upstairs to read, top secret or top secret, right? You cannot write down. I'm saying if you are at top security floor, you cannot go downstairs and leave notes on confidential floor. That's how I would simply say. Three rules: simple confidential rule, star confidential rule, I'm sorry, confidentiality rule, and a strong star confidentiality rule. So two things that we have to always consider: no read up and no write down. So that's our first model. So we got another model called Biba model. So when I say Biba model, I'm basically saying it's not first. Let me Biba model emerged as a direct response to the Bell-LaPadula model. Bell-LaPadula model was more on confidentiality of the data. So this is basically addressing integrity concerns that Bell-LaPadula does not cover. So it was developed by Neith, J. Biba in 1977. So this formal state transition system established a set of access control rules designed to explicitly maintain the data integrity across the system, right? So here also we have three rules, simple integrity rules, star integrity rules, and strong star integrity rule, right? So let's say you are at one level, so you cannot once again, read down. You cannot see what's there. That's what no read down. And then you cannot write up. So you know write up. So if you remember, in here we say no read up, no write down. So the integration of integrity Biba model for data integrity, no read down, but you can read up. And no write down, so no write up that you can write down. So that's how it's a bit of a, and the third level, which is called the strong star integrity rule, sorry, that basically allows you cannot see beyond what you have been basically given the clearance of the access. So in Biba model, both data and subjects are categorized according to their reliability and integrity levels. The model basically aims to prevent data corruption by restricting how information flows between different, integrity levels, creating a structure that is, in many ways, the inverse of Bell-LaPadula. So no writer prohibits subjects from modifying data at higher integrity level. This prevents potential less reliable sources from corrupting more trustworthy information, right? And no read down prevents subjects from reading data at lower integrity. This protects against the contamination by stopping more trusted process from incorporating potentially less reliable information, right? So if I ask you that, what example can it be, which is going to be good? So I'm going to say, like, let's say a doctor system is a higher trust, cannot read what receptionist or receptionist data, which is a low trust rate, right? But when I say no write up, so a receptionist, cannot write or update the doctor's records or prescriptions and all those things. So doctor does not see the receptionist things, and then receptionist cannot overwrite the doctor prescriptions or things, but it's okay to see that it can read but cannot write. So that's one of the examples I can give. Okay, so there you go. The last model that I'm going to discuss with you today, that's called Clark-Wilson model. So Clark-Wilson model is not like a layer-based or level-based, as we discussed that. So let me give you a brief history about that. So this Clark-Wilson security model was developed by David D. Clark and David Wilson. So that's why we call it the Clark-Wilson model. So Clark and Wilson represents a significant evolution in security modeling with its focus, on commercial and business applications, rather military contacts like unlike Bell-LaPadula and Biba, which emerge from military security requirements, basically. So Clark-Wilson addresses the specific integrity needs of commercial systems where transactional consistency is permanent, like banking systems and all those things. So, the model's primary goal is to formalize the concept of information integrity by preventing, data corruption due to, either errors or malicious activities. It established framework where data items maintain their validity as they transition between system states, right? So it enforces through well-defined procedures and, separation of duties. So the core components here are, let's say, if you have a data item that is unconstrained, you can directly access. But if the data item that is constrained, you have to, now start thinking of, protecting it. So when you are protecting it, so basically the Clark-Wilson model, like let's say this model, does things in two major processes. One is the transformation process, and another one is called integration verification process. So in the transformation process, so it's a well-formed transaction that modify constrained data items according to integrity rules. So all the integrity rules are there. These procedures ensure that the data changes maintain the consistency and the flow prescribed prescribed certification standards, right? So that's the transformation. And the second one, that's called integrity verification procedures, IVPs. So they process that confirmation data integrity by verifying that all constrained data items conform to validation specification. So these procedures perform authentication and authorization checks before granting access. So that's why, like, if you see that if you don't have access from here, so you cannot directly access that. But with LaPadula, you can basically go. So the Clark-Wilson model has found a widespread application in financial systems, enterprises, source planning, ERPs, platforms, and other business critical applications where transactional integrity is essential. This translates in addressing practical commercial security. So if I ask you, if I give you an example, then how? So it's basically, let's say, a user, or teller submit a request. So, and in the banking process, basically apply all those rules to, this transactional process or IVPs, and then checker basically approves the transaction. So you have layered workflow where no one can directly basically touch the sensitive data without passing through the rules, right? So that's all. So only thing that I would definitely give you, that it basically accurate infrastructure inventory. It's one of the benefits if you implement the how to say, like, security models, and and also it's enhanced monitoring. Enhance other systems or robust security models, incorporate advanced monitoring capabilities like security information, event management, security orchestrations, automations, and network detection response. These systems analyze logs and events to identify security concerns in real time, enabling faster and threat detection and response by security operations and personnel, right? So, of course, we have other benefit, which is called cost efficiency. So it's reduce security incidents, lowers the cost. I think that's all for today. If you got any questions, please do not hesitate to leave me the message. Thank you so much, guys.